Hi, this video is going to cover the different ways to combine COBOL and Java programs in isCOBOL. Now the main concern when you're doing this is passing data back and forth in the correct format for each language. Let's talk about going from COBOL to Java first. One way to call a Java method is to use object-oriented programming in a COBOL program. Now there are three basic parts to this. You add a repository section and you list the Java classes that you need. And then you declare an object reference to access any dynamic methods in the class. And then you use either the direct method or the invoke syntax to call the methods of those classes. Now here's an example of both. Now if the method throws an exception, you'll need to use a try-catch block to catch and handle the exception. Now, though COBOL programs usually access a Java program this way, with object-oriented programming, it can also be done with a plain call statement, as if you were calling any other program. However, you can only use that call statement to call Java programs that implement the isCOBOL call interface and include a method exposing the call object. If you don't have these two things in the Java program, then you have to use object-oriented programming instead of just a call statement. Now, because of these requirements, you can only call Java programs where you can control the Java code. And that means the call statement is usually used when you're transitioning to isCOBOL. Either you're replacing a C function or similar with a Java function, or you're replacing a library routine that's missing in isCOBOL. Now, to help the Java programmer fulfill the requirements in their Java program, we have a tool called Linkage, and it'll create a Java stub program for each call statement in your COBOL program. And this gives the Java programmer a starting point to interacting with your COBOL program without having to understand your COBOL code. Now, here's an example on the screen of a COBOL code call statement to func-initialize. Linkage generated a stub program that starts with the statement shown on the right in the table. To generate these stub programs, you would set Linkage to the value of 2. But the most common usage of Linkage is when you're going the other way, from Java to COBOL. If you set Linkage to 1, it'll automatically generate a Java bridge program that handles the communication between your COBOL program and the Java programs. Now, the bridge program that gets generated by setting Linkage to 1 uses the COBOL program's linkage section, and it takes care of passing data correctly between the two languages. It also contains a run method so it can call the COBOL program. Now, we're going to look at several examples of this in the demonstration. Linkage uses the two classes available to the Java programmer to interact with isCOBOL. isCOBOL.Java and isCOBOL.RTS. isCOBOL.Java contains methods to run the COBOL program and to handle the exception caused by a stop run. isCOBOL.RTS has a utility method called COBOL-var-helper that will handle the data conversions needed to pass data to and from the COBOL program, and a method to handle any exceptions that get thrown. There's some screenshots of code on this slide, but we're going to look at it deeper in a demonstration. So let's go do that. All right, I'm going to start with the most basic object-oriented programming I could make, and that is the cc.cbl. I went out and got a Java program that does nothing but display colorful circles in a screen. Let's open up the little program. And here's the repository section with my class in it. I don't need an object reference because I'm calling a static method. And then down here, I have the direct method of calling the main function in colorful circles. I could have also used this syntax with the 2 colons instead of the colon greater than. Or I could have used the invoke statement. All 3 of these statements do the same thing. So let's run this. And that's what the program does. All right, that is the simplest object-oriented programming. But of course, we're going to need to get into it a little bit deeper. So let's go look at our samples. And they're in isJava in the sample folder. And I first want to look at isCOBOL uses Java object. Now there are 3 sets of samples in there. We'll look at the invoke versus direct first. And we'll pull them both up and view them together. And so that they're side by side. Now in the repository we have our class. In this case we're getting the system class because we want information about the system. The system class doesn't have a constructor. All its methods are static, so we don't need an object reference. We'll talk about that more in a little bit. And so in the direct method, to get, say, the operating system name, you would use this statement. In the invoke method, you're going to use this statement. Both of those things highlighted in blue do the exact same thing. And now let's go into the static versus instance, and I'll talk some more about this object reference. Our class in this case is Java IO file, and we do have an object reference for that class that we call JFile, and we're calling that object reference obj file. In our code, we're getting a couple of variables that are static variables, and then we're going to create a temporary file, and then we're going to get the canonical path for that file. And that path is a dynamic method, so we will need that object reference. So here we're setting the object reference to the temporary file, and then we're using that to get its path. And then it's going to say that it created it and information about the file. And then we're resetting the object reference, and then we're going to set it again using that file, and then find out if the file exists and if it's a directory or not. So this program will show you the difference between handling a static method and a dynamic method. So let's run that, clear the screen. And there's our separation character. It created the temp file, and then it told us that the temp file existed and that it wasn't a directory. Simple programs, but we're using that to show you the different pieces that you need for the object-oriented programming. Now we have a couple in the Others folder that you should know about. One creates and then reads an Excel spreadsheet, and the other one sends email. And both of them are fairly extensive object-oriented programs. So let's take a look at the Excel. You can see our repository is quite a bit bigger here. We have a lot more object references. And then the program will just make a simple Excel file, and you can use this and add what you need to this code. Okay, and then the other one is mail, and it uses send mail. Let's take a look at that. A few less repositories, but still pretty good set of them, some object references. In this program, all you have to do is replace this information with your server information, and then replace this with the information you want to email, and you can use this to send emails from your program. Now let's look very shortly at isCOBOL calling Java with a call statement. We'll clear the screen and we'll go to isCOBOL call Java. And I'm going to just go to the isCOBOL call first. And we have a main program, and it calls a Java class called jprog. Jprog is something that we've written, so we have control over it. We can put in the information that the Java class needs. So we'll look at main, and here's our call to our Java program. And we will look at the Java program, and here you can see we're implementing the isCOBOL call, and we have our call object here. So because we can control this Java code, we can just call it from our COBOL program. And I mentioned that EasyLink set to 2 will create a stub program for those calls. So let's look at that. In this case, my prog will call a bunch of libraries and routines that don't exist. So when we compile this with EasyLinkage set, it's going to create a stub program for each one of these calls. And the reason it does that is because compiler properties that we use is setting isCOBOL compiler EasyLinkage to 2. All right, now I have done that, and the compiler created a folder called EasyLinkage, and in EasyLinkage are all of the Java classes that were generated. Let's take a look at one of them. and it generates the code that is required, the implementation of isCOBOL call, and the object call here. And then it has a commented out block that your Java programmer can use to put whatever Java code you need in there. Now for this test, I'm just printing out a line saying that I'm in each one of these stub programs. And I've done that for each one and compiled them. So let's run the program. Clear screen. And we're going to follow the instructions in the README. I've already compiled. I'm going to set my class path. And then I'm going to run the program. And all of those calls to each one of those stubs, I put in a hello saying where we were, and you can see that that code is getting executed. Okay, so that's COBOL calling Java. Let's talk about Java calling COBOL. Clear the screen here. And let's go to the Java call isCOBOL folder. We have two sets of examples here. I want to go to the easy linkage. Now we previously used easy linkage set to 2 to create those stub programs for the calls. But in this case we're going to set it to 1, and it's going to create a bridge class so that you can have your COBOL program, the Java programmer can have his Java program, and the two programs can talk to each other because of this bridge class. So let's clear the screen, and let's look at how I compiled this. So here's my line to compile my COBOL program, and I'm setting easy linkage to 1 in my statement here. I'm compiling it for debug. I'm creating the Java code and not getting rid of it. That's what the JJ and JC does, so that I can create Java doc later. And there's my COBOL program. Then I set my class path like we did last time. Then I'm using the Java compiler to compile my Java program that I have. So let's run that. So now everything is built. Clear the screen. Now I want to debug this, but because the COBOL program is not being called directly, it's being called from Java, I need to run the remote debugger. So I have a command to do that, and there's my remote debugger waiting to listen. And if you would like more information about running the remote debugger, there is another video about that. And then I'm going to run this in the debugger. So I have a batch file called rund, and there it is in the Java main program. Then it calls the COBOL program, and my remote debugger comes up. And I can step through there, and it displays the variables that it got, and then it changes the values and sends it back to the Java program. And note my linkage section. That's very important. That's what you're using to talk back and forth to the Java program, and that's what easy linkage zeroed in on when it created that bridge program for us. So I'll step one more time, and we're back. Now to see what happened, I didn't show you the console output, but we're just going to run this outside of debug. And here's the values that were passed to the COBOL program, and then the values that were passed back to the Java program. All right, and I did say that I was going to create some Java doc. If I'm going to go into my easy linkage folder that was created when I compiled it, you can see that I still have the Java portion of my program. So I can run the command that's in the README to create my Java doc, and that's this command here. And there's the Java doc for my COBOL program for the Java programmer. All right, let's go look at the last thing, and that's the COBOL var helper. And this sample does a lot of stuff with data. It goes back and forth using the COBOL var helper. It also gets information and passes information through environment variables, and it handles exceptions. So let's take a look at the Java program. So it's going to call cobprog1 3 times, adding to the value that's passed back and forth, and then it's going to cancel it, which will reset the value and then display the beginning value again. Then it's going to do something similar. It's going to call cobprog2 with 3 variables. And while it's in there, it's going to get the value of an environment variable. And then the third thing it does is it's going to get a whole bunch of different types of data so that you can see how each type is handled. It's going to pass it back and forth, and it's going to set an environment variable and then pick it up in the call. Then COBOL 4 will be called. That one has an error. It's going to try to call a program that doesn't exist, so you can see how this error is handled. And this last one will call a COBOL 5 that has a stop run in it. If it doesn't have a go back, it has a stop run. It needs to be handled. And this shows you how to do that. So let's go run this. Again, I need to run the remote debugger because the COBOL programs are being called from Java. There it is listening. And then I'll run the Java program. And it gets the first call, gets the COBOL program, and it brings up the debugger. So let's step through it. And all these displays are coming out in the console here. And then it calls it a second time and a third time. You can see the new value is increasing. And then remember the Java program cancels it, so it should be 1 now, and it is. All right, now we're in COBOL 2, which passes 3 variables, and it gets an environment variable. Now we're in COBOL 3. Remember, that's the one with a bunch of different types of data variables, just to show how it handles this data. It's going to go through and list all those to the console, and then it's going to reset them to a different value, send it back to the Java program. Now it's in COBOL 4. We're going to call a non-existent program, and the Java program will handle that. And now we're in COBOL 5, and it has a stop run, and the Java program will handle that. And there's an introduction to interacting between COBOL programs and Java programs using isCOBOL. If you have any questions, as always, you can reach us at support@variant.com. Thank you.